So let us try to derive the equations for backpropagation. Now let us consider the RNN architecture where we have three timestamps and so we have a time t is equal to 1, we have x1 with weight matrix U and it produces let us say h1, and we know that we have feedback connection because it is an RNN, and here we have h1, we are sending another word x2 when time is equal to 2, and h2 is sent here with same again x3 with weight matrix, and with this comes with another weight w, and here comes h3, and from h3 we'll be calculating y cap with weight v. So the equations that we can write here is y cap is equal to sigmoid of v into h3 plus the output weight v naught. And what is h3? h3 is activation function tan h into u into x3 plus that particular bias plus input weight, hidden weight vector w into h2. And h2 is a function of ux2 and also a function of h1. And h1 is a function of h0. So what we do in backpropagation? In backpropagation, we calculate loss or error. Let us say it is E. What is that? E is a function of the actual value and the predicted value, the difference. And we want this to be minimum. So in backpropagation, we try to calculate U, V, W. Why we want to calculate them? We want to calculate them when the error, the gradient E is equal to 0 or minimum. So if you calculate this gradient, we can calculate the new set of weights as old set minus learning rate into the gradient. Similarly, V dash is equal to V minus learning rate into dou E by dou V. And similarly, we have W dash new set of weights is equal to old set of weights minus learning rate into dou E by dou W. So we want to find U and VW such that error gradient is minimum. So this is our task in backpropagation. Let us try to derive that equation. So firstly, let us try to calculate dou E by dou V. So it is somewhat straightforward because E depends on y cap and y cap depends on the V. So here I can write it as dou E by dou y cap cap is a function of V and H3. So I can write it here, dou y cap by dou V. This is somewhat straightforward here. Then, secondly, when we consider dou E by dou W, the situation is not that simple because this is E here. You are calculating E here, and this there we have one W here. So this will be influencing. Then we have W here, they have W here. The summation of all these three. So this error depends on H3, and H3 will depend on W of H2. So here, let us make a chain. Error will depend on Y cap. Y cap will depend on, what is the equation for Y cap? Y cap will depend on H3. H3 as well as that, okay, that weight we have already seen. And H3 is calculated from W and H2. Because partial derivative, I am considering all these things as constant. So H3 depends on weights and H2. And H2 depends on the weight W and H1. H1 depends on the weight and W, H0. So to calculate error with respect to W, I have one chain here. This is one chain, and this is the second chain. This is the third chain. So I write here, this is equal to, firstly, this one, dou E by dou Y cap into dou Y cap by dou H3, and dou H3 in turn depends on dou W. Plus, that's the first term, first path. Second path, dou E by dou Y cap into dou Y cap by dou H3. This H3 depends on H2, dou H3 by dou H2 into H2 will depend on W. Similarly, plus then H3, H2, H1. Dou E by dou Y cap is dou Y cap by dou H3, dou H3 by dou H2, and dou H2 depends on dou H1 into dou H1 is influenced by dou W. This is what. So summation of these three terms. Similarly, we can also calculate dou E by dou U in the same similar fashion because the equations are same. I can write here dou E by dou W, dou U is again, firstly it is depending only on H3, dou Y cap by dou H3, dou H3 is influenced by U, plus dou E by dou Y cap, dou Y cap by dou H3, dou H3 is again influenced function of H2, dou H2 dependent on dou U, plus dou E dependent on dou Y cap into dou Y cap dependent on dou H3, dou H3 dependent on dou H2, dou H2 is dependent on dou H1, and dou H1 is dependent on dou U. So this is known as backpropagation through time in RNN. In the next class, we'll see why this is difficult. What are the problems we face through this backpropagation in RNN?